All right, here we go. We're on part two now. Sorry that we had to make this part two. Make this as quick as possible so we can get this done and out of here. We just finished up proving that the mid segment is absolutely half of the third side of the triangle. And so since we did this in a coordinate proof, we can do this with any number or anything, okay? So let's go ahead and look at this on a graph. Let's do it. All right. So here is a graph, a Cartesian plane, an actual Cartesian plane or coordinate plane for those of you guys who aren't familiar with the Cartesian plane. And here's what we're going to do. We are going to go ahead and work this out. Let's make this check to see if all this. So we're going to prove the same thing we just proved, but now we're going to actually use a Cartesian plane. Okay, so if we're looking at a graph, how do we find the distance on a graph? Well, if everything was horizontal, like we'd like it to be, then you would be able to count left to right. In this case, we have a lot of slants, so we have to use the dreaded distance formula. That is right. That is your square root of x minus x squared plus y minus y squared. All right, so here we are here. Just to kind of keep it brief, if I do the distance formula here on CD, you take your 1 and 1 and you take your, let's see, that's 6 and 6, excuse me, 8 and 8, then you end up having a, not slope, that's not what I want, sorry. You end up having a distance of CD that's 8.6 meters. Okay, if we do the distance here, okay, from B to A, we're going to take our point negative, well, that's right there in the middle there. And we do the distance formula there, we end up with a distance of 4.3. So if you do 8.6 divided by 2, you will get 4.3. Or if you do 4.3 times 2, you get 8.6. So again, this is just, I'm making it brief and short, but what we did was we took this triangle, we took what we think to be or what we thought to be the mid segment, and now we just found the distance using actual numbers versus what we did a minute ago or on the last video with variables. We use actual numbers to prove that this is actually the case. Now again, please don't miss what I'm saying here. In order to find this distance of 8.6, we had to do the distance formula. I mean, and again, I'm saving time here by not going through the distance formula because truthfully, you guys should be able to do that by now. We've done it pretty much on every chapter since I think chapter 2. So you guys should be good with distance formula. Once I plug point D and point C in the distance formula, I end up with 8.6. Point A and point B into the distance formula, 4.3. You compare these two numbers. 4.3 is half of 8.6, which we expected to be. Again, same thing we did in the last one. If I want to count slope, slope's a little easier for these. I can just count my rise over run, right? So my slope here of CD is up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7. So 5/7, which is about 0.71. This particular program that we use here, is not real good about keeping the fraction. Okay, same thing here. We count our rise and the run. We end up with a slope for AB of 0.71. And again, why are we concerned about the slope? If slope AB is 0.71, slope CD is 0.71, what does that tell us about our diagram or our figures? Well, it just tells us the mid segment and that third angle, the third side of the triangle are parallel. Okay, they're parallel. So mid segments are always parallel and half of the third side. So basically, the mid segment theorem is simply that. Okay, so we spent this whole time, this whole 20 or 25 minutes on proving that the mid segment of a triangle, where you connect, this is just kind of a recap, where you connect the midpoint of one side of a triangle to the midpoint of another side of the triangle. That's what you did there. Once you do that, that's called the mid segment. The mid segment is always parallel to the third side, and it's always half of the third side. Okay, that's what we basically did this whole time, and we used a coordinate proof to help us with that. Okay, if you have any questions, please, please, please feel free to ask. I know this is kind of a different lesson, but it's essential nonetheless. So, here is your classwork. And I will see you guys tomorrow.